In this video, we are going to find the volume of a parallelepiped. A parallelepiped is a parallelogram that has been joined together to form a solid figure. So, if you check this, you see that on every side of the parallelepiped has been slanted. So, what is the volume? The volume of a parallelepiped is equal to the area of the base, which is A, times the perpendicular height, and in this case the perpendicular height is h. So let's first find the area of the parallelogram. So I am taking this base, the base of this parallelogram out. So that is what I have drawn here. So you see that this is vector B, and then this is the vector C. Now, what is the area of this parallelogram? The area of a parallelogram is given as the length of the base. So the length of the base, then multiplied by the perpendicular height. So it is length of the base times the perpendicular height. That is the area of a parallelepiped. So in this case, it is going to be the vector B times h. So we need to find h. But you can see that sine phi is equal to the opposite. Using SOHCAHTOA, sine is opposite over hypotenuse. So the opposite is h over hypotenuse, which is vector c. So magnitude of the vector c. So in this case, h is equal to the magnitude of vector c sine phi. So therefore, the area of the parallelogram is given as the length of the base, and the length of base is vector B. So it's going to be magnitude of vector B, then times the height, and then the perpendicular height is magnitude of vector C sine phi. However, we know that the vector B cross the vector C is given as magnitude of the vector B times the magnitude of the vector C sine phi. So therefore, the area A is equal to vector B cross the vector C. So this is the area. But then we see that because it is a cross product, B cross C is also the same as this perpendicular height. So let's say this is D. So in other words, D is equal to vector B cross vector C. So we have found the area. What is left is to find the perpendicular height in this case. Now, what is cos alpha? Cos alpha is equal to, cos is adjacent over hypotenuse. The adjacent is h divided by the hypotenuse, and in this case the hypotenuse is magnitude of vector A. So in making h the subject, h is equal to magnitude of vector A cos alpha. Now let's find A, vector A dot vector B cross vector C. This is equal to magnitude of vector A, then times vector B cross C. We have established that as D. D is equal to B cross C. So times D cos the angle between vector A and then vector H. So that is alpha. So now this can also be written as D times magnitude of A vector A cos alpha. But then we have already established what magnitude of A cos alpha is. That is the perpendicular height. And therefore this is equal to DH. What is D? D is what we found here, which is what? B cross C. And then B cross C is the area of the base. But we've already said volume is equal to area times the perpendicular height. And therefore, this is equal to D is the area of the parallelogram, and then H is the perpendicular height. So therefore, by deduction, you can see the volume of a parallelepiped is V equals vector A dot vector B cross vector C. This is what in mathematics is also known as triple product. So we are going to use this formula, volume equals vector A dot vector B cross C, to then find the volume of any parallelepiped that we are given. Find the volume of the parallelepiped with edges vector A equals 3i plus 2j plus k, vector B equals 2i plus j plus k, and then vector C equals I plus 2j plus 4k. So the volume of a parallelepiped is given as vector A dot vector B cross vector C. So the first thing we need to do is to find vector B cross vector C, and that is equal to, using the form of determinant, here's I, here's J, and this place is K, and then vector B is 2I plus J plus K, then vector C is I plus 2J plus 4K. So let's go ahead and then solve it. So let me continue from here. So the first thing would be I. So having written I, then so this is equal to I, then we will delete the row and then the column of I and write the remaining 2 by 2 vector. So this will be 1 1 and then 2 4. Then minus J, remember we are using plus minus plus, so minus J. Then we delete the row and column of J. We are left with 2 1 1 4. So here's 2 1 1 4. Then plus K. We will delete the row and then the vector of K. So we are left with the 2 by 2 matrix, which is 2 1 and then 1 2. So simplifying further, this is equal to I. Then you multiply the diagonal, the leading diagonal, and subtract it from the other diagonal. So here is 1 times 4 minus 2 times 1. Then minus J, 2 times 4, then minus 1 times 1. Then plus K. And then K is 2 times 2 minus 1 times 1. So this is equal to I. Then 1 times 4 is 4, minus 2 times 1 is 2. Then minus J, 2 times 4. 2 times 4 is 8. Then minus 1 times 1 is 1. Then plus K, 2 times 2 is 4. Then minus 1 times 1 is 1. So this is equal to 4 minus 2 is 2. So 2I. Then 8 minus 1 is 7 times minus J becomes minus 7. 4 minus 1. 4 minus 1 is 3. So it becomes plus 3K. So we found B cross C. So let's then find A dot B cross C. So the volume V is equal to A. Vector A is 3I plus 2J plus K. Then we will dot it with this B cross C, and B cross C is 2I minus 7J plus 3K. So this is equal to 3 times 2. You multiply the correspondence. So 3 times 2. Then plus 1 times 3. So this is equal to 3 times 2 is 6. And 1 times 3 is 3. So this is equal to 6 minus 14 plus 3. 6 minus 14 plus 3 is equal to 5. So the volume is equal to 5 cubic units. The formula for the volume of a parallelepiped is given as into bracket vector A cross vector B dot vector C, when vector A is equal to 2i minus 2j plus k, vector B equals 2i plus j, and vector C equals 3i plus 2j plus k. So the question is requiring us to find the volume, and they've given us the formula for the volume as into bracket vector A cross vector B dot vector C. So the first thing we need to do is to find vector A cross vector B, and this is equal to, so we write the determinant I, j, k, and then vector A is 2i minus 2j then plus k, and vector B is 2i plus j. It means that the k is 0. So let me continue from here. This is equal to I. Then you cancel the row and column of I and write the remaining 2 by 2 matrix. So it will be left with minus 2, 1, 1, 0. So minus 2, 1, then 1, 0. Remember, we are using plus, minus, plus. So here becomes minus unit vector j. Then you cancel the row and column of j. You are left with the 2 by 2 matrix, which is 2, 1, 2, 0. So here's 2, 1, 2, 0. Then plus unit vector k. And you cancel the row and column of k. You are left with 2 minus 2 and then 2, 1. So 2 minus 2 and then 2, 1. So this is equal to I. Then you multiply the leading diagonal and subtract it from the multiplication of the other diagonal. So this becomes minus 2 times 0 minus 1 times 1. Then minus unit vector j, 2 times 0 minus 2 times 1. Then plus unit vector k into bracket 2 times 1. Then minus 2 times minus 2. So this is equal to I. 2 times 0 minus 2 times 0 is 0. Minus 1 times 1 is minus 1. Then minus j. 2 times 0 is 0. Minus 2 times 1 is minus 2. Then plus unit vector k. 2 times 1 is 2. Then minus 2 times minus 2 is plus 4. So this becomes minus I. Then here is minus j times minus 2 becomes plus 2j. Then 2 plus 4 is 6. So plus 6k. So this is vector A cross vector B. So having found vector A cross B, let's go ahead and find the volume, which is equal to vector A cross vector B dot vector C. So vector A cross vector B is minus I plus 2j plus 6k dot vector C, and vector C was given as 3i plus 2j then plus k. So this is equal to, you multiply the correspondence. So in one bracket you have minus 1 times 3 then plus 2 times 2 and plus 6 times 1. So this is equal to minus 3 plus 2 times 2 is 4 plus 6 times 1 is 6. Minus 3 plus 4 is 1. 1 plus 6 is 7. So the volume is 7 cubic units.